Right now, sitting in the dark, your body is emitting a faint, pulsing light. It is incredibly weak, invisible to the naked human eye, but it is a verified biological fact. We actually glow. What makes this strange is what happens at the end of an organism's life. At the exact moment of death, this light emission experiences a sudden, intense spike before fading out completely. It looks exactly like what we've been told a spirit leaving the body should look like. For nearly 100 years, that visual similarity sent researchers down a very strange path. In the 1920s, Russian biologist Alexander Gurwitch observed this light in plant cells. He proposed that cells used invisible radiation to communicate, sending telepathic signals to tell each other to multiply. Over the decades, others built on his work. By the 1970s, researchers like Fritz Albert Popp suggested that human DNA acts like a cellular radio, using light particles to orchestrate the entire body. Later, Konstantin Korotov took this to its limit, claiming the burst of light escaping a dying body was physical, measurable proof of the human soul. The scientific community fractured over this. The detection tools they had were so weak that the data they produced was chaotic, leaving room for researchers to project their own theories onto the noise. Solving the mystery of the human glow became a forensic challenge. Early investigators were simply limited by the low resolution of their sensors. By the late 1990s, a new generation of researchers decided to strip away the mysticism and approach this strictly as a problem of biophysics. Masaki Kobayashi, a skeptical researcher from Japan, wanted to find the exact biological root of the glow. To do it, he used a piece of hardware miles ahead of the old equipment, a charge-coupled device or CCD camera. By cooling it to minus 120 degrees Celsius, his team eliminated nearly all thermal interference. This sensor data demonstrates why the cooling matters. Once it clears away the static noise, the camera can pinpoint the exact physical location and timestamp of a single light particle in real time. Kobayashi finally had the capacity to interrogate living tissue accurately without the spiritual guesswork. He set up a definitive experiment, hooking up a live rat to monitor its brain for electrical activity, oxygen levels, and photon emission all at the same time. The results showed a direct correlation. The rat's brain produced the most light specifically when it was under intense metabolic stress. The culprit generating this light was a chemical exhaust produced by normal cellular metabolism, known as reactive oxygen species, or ROS. ROS are unstable oxygen molecules. Missing electrons, they aggressively tear through the body, colliding with nearby proteins and DNA to steal electrons for themselves. When electrons are violently pushed from their bonds, their momentum releases energy. We perceive this microscopic energy release as a photon of light. The light observed at the moment of death represents the final, violent breakdown of cellular machinery, as it releases a concentrated burst of chemical exhaust. To prove this link, Kobayashi intentionally infected a plant with a virus to trigger a severe allergic reaction. As the plant's stress and ROS levels spiked, the plant glowed brightly. Then he injected it with an antioxidant. Antioxidants naturally neutralize ROS molecules. The moment the injection hit, the plant's glowing faded, confirming ROS was the sole cause. For decades, an entire industry of aura readings and mystic literature had been built around a complete misunderstanding of a simple chemical byproduct. This physiological map of human tissue shows the real-world application of this discovery. Healthy cells emit a low baseline glow, but cancer cells, which multiply uncontrollably, generate massive amounts of ROS exhaust, making them glow up to 4 times brighter. By tracking this bioluminescent exhaust, doctors can literally see the microscopic distress signals of disease, detecting cellular abnormalities long before a physical tumor forms. Our bodies possess a bioluminescent early warning system. By reading these trace emissions, we can identify life-threatening conditions years before they become visible on a traditional scan.